Bonjour Adela. I hope you are doing well. So I hope with this video, I'm very sorry that we weren't able to discuss this together at the same time, but this video aims to show you how I have taken the data that you sent me in terms of the national energy balances for DRC between 2000 and 2012 and uploaded that data into LEAP to estimate emissions for the energy sector. So I'm going to try and go through how I have entered all of that data into LEAP and how to then view the results and to make a comparison to the emission estimates that you had in your third national communication. So the first thing that I want to show you is that you sent me these energy balances as separate files. In the Excel file that I've sent you, I've combined them all together into one file with each energy balance represented by a different sheet. In the sheet summary for LEAP, I've then taken the key statistics in terms of energy consumption that we need for each sector and put them into a format that allows us to enter them into LEAP. So if we take as an example the commercial and public services sector, what I have done here is then imported for each year the value in terms of the total energy consumption in 2000 in commercial and public services for bois de feu or for charbon de bois for each of the types of fuels. Now, a lot of these are zero. In commercial and public services, it's just electricity consumption that is accounted for. So if I look at, say, 2012, in 2012, it is estimated that there is 105,000 tons of oil equivalent of electricity consumed. And if I go to LEAP, if I go to the sheet for 2012 and look to commercial and public services, the electricity consumption is 105,000. So these data here in terms of the total electricity consumption has been taken directly from the energy balance. And I've done that for commercial and public services, for industry, for agriculture and forestry and fishing where there was no energy consumption included, for the residential sector, for air transport, for road transport, for rail transport, for other transport, and for domestic shipping, taken the energy consumption of all different types of fuels. Now, the data that we need to enter into LEAP is all in green. So it's further below. We don't enter this directly, the energy consumption for different fuels. We need to enter the total energy consumption. So this value here is just the sum of all the individual fuels for each year. So in this case, it's the same as electricity. This is our total consumption. And then we need to say what percentage of that fuel is consumed as electricity or as different types of fuels. We need to know the fuel share, the percentage share of different types of fuels. So for commercial and public services, it's easy. We just have electricity consumption. And therefore, here under total consumption, we just have the value for electricity. And then 100% of our fuel share is electricity. So then let's look at how that is entered into LEAP. So if I go to LEAP, I have now my data set for DRC. And under the demand sector, I have 7 different subsectors: residential, commercial and public services, transport industry, agriculture, energy industry, own use, and other. If we go to commercial and public services, I then have all. So I have an activity level. This is an estimate of the activity within our sector. Now this is really only used when we're making projections, but this is an estimate of the total activity in that sector. I then have my total, my final energy intensity, and that is calculated by an equation. We don't enter this directly. And this is the total consumption divided by the total activity. So the units are tons of oil equivalent per US dollar, per unit of GDP. So we don't enter this directly. We get the total activity from here, and our total consumption is from our spreadsheet. It's entered directly as an interp function. Now when I did that, all I did was copy the years and the values. I went to Leap, and then I pasted that into this space. There was no need for me to write out this long expression. I just copied and pasted it from Excel because I'd put it into the correct format already. Then I didn't need to do anything here. The value for electricity was 100%, so I didn't need to split it between my different fuels. It was just for electricity. So the fuel share was 100% electricity. Let's look at a more interesting example. Industry. Industry, I have consumption of fuel oil, and I have consumption of electricity. So in this case, my total consumption is the sum of my fuel oil plus my electricity. So I've got two fuels represented in my total energy consumption. Then my fuel share says that there's between 24% of my total energy consumption is fuel oil, and then the rest is electricity. So let's look at how that is represented in Leap. And again, I entered these data by copying the year and copying the value and pasting it into Leap. If we go to industry, I've got all industry together, no disaggregation. Again, the activity level is GDP. We don't need to worry about that. Total consumption divided by total activity for the final energy intensity. The key variables that we've entered is the total consumption in tons of oil equivalent. And we've got our time series for 2000 to 2012. And then the fuel share. So if I scroll down, I've just copied in the value for heavy fuel oil, and it's created this interp function here. So this, I copied these percentages with the years and pasted it into Leap like I did for the total consumption to give me my fuel share for heavy fuel oil, and the rest electricity. Agriculture, forestry and fishing, no data. Residential, I've got different types of fuels being used here. Bois de feu, charbon de bois. So I've got wood, I've got charcoal being consumed. I've got a little bit of kerosene or pétrole lampon, and total electricity here. So I needed to enter all of those. So if I go to residential and then all, again I've got my activity level. In this case it's the population, the number of people. Final energy intensity calculated the same, don't need to worry about that. And then my total consumption, I've just copied these values and then pasted them into total consumption and click paste. Exactly the same with the fuel share. I've entered the fuel share for kerosene, the fuel share for wood, the fuel share for charcoal, and then the rest, the remainder, is electricity, to make sure everything adds up to 100%. The transport sector, done the same thing. So we've got aviation, jet fuel kerosene is used, total consumption jet fuel kerosene. Road transport, I've got essence, which is gasoline, I think, then diesel, and it's about half each, diesel and gasoline, and my total consumption. Rail, all electricity, and then domestic shipping is diesel. So if I look into LEAP, I've got my road transport, and here I've got my total consumption, and then my fuel share for gasoline, the rest, fuel share for diesel, the rest is gasoline. Rail, total consumption entered here, fuel share is electricity. Aviation, total consumption entered here, fuel share, all kerosene. So that's how I've entered the data that is available from your energy balances. There are a couple of ways in which this could be improved, or there were a couple of questions that I had. The first one was that for commercial and public services, there is only electricity consumption. When we've been developing emission inventories for other countries, there has been often been consumption of wood or charcoal in commercial and public services, in restaurants, for cooking and things like that. Is that something that takes place in DRC, or and the data just wasn't available, or do you think this is accurate? Do you think this is correct? The second question was that in order to improve the estimates of road transport emissions, it would be really useful to look at a more detailed methodology. But for this, we would need to know the number of vehicles in each category, the number of passenger cars, the number of buses, the number of heavy-duty vehicles. And I wonder whether that is available or not. It would be very interesting to find out. I think the simple method is okay, but it'd be it would be really nice if we had a more detailed methodology there. That's the demand sector. LEAP as an energy model is a demand-driven model, which means that in demand we estimate the consumption of different types of fuels, of electricity, gasoline, of diesel, of kerosene, of wood, of charcoal. That then gets fed through into our transformation sector, where we estimate the emissions from electricity generation, from oil and gas, from charcoal making. So what I want to emphasize here is that we don't estimate the emissions from electricity. We don't put into electricity generation the total amount of electricity generated. We do not enter the total electricity production from your energy balance. That is calculated by LEAP from the data that we enter into demand. So what we need to do for electricity generation is first put in our transmission and distribution losses. So we need to say how much electricity we are losing in transmission and distribution. And that data was available from the spreadsheet, from your energy balance. So I have calculated that here to calculate the percentage of electricity that is lost. So for example, if we look at electricity here, we have the total, let me just check the equation. So we have the total electricity consumed, the final consumption, 535,426. We have the total energy produced, 652,826. So this is the losses. This is how much is consumed. This is how much is produced. So the difference between those gives us our loss. And I've calculated that as a percentage here. And it decreases over time, which is good. So I've entered that, again, copying and pasting into this expression. Then for our electricity generation, we don't put directly how much electricity is consumed. We put in the amount imported and the amount exported, which I've taken directly from your energy balance. So electricity generation, we have our exports and our imports taken directly from the energy balance. They've been entered directly here. And then for domestic electricity production, I put in how that electricity production is produced. Whether it is produced from diesel, which is a very small amount, or from hydro, which is the rest. And I wanted to ask you whether that was accurate, whether it was just diesel and hydro that is used to generate electricity in Democratic Republic of Congo, or whether there are other fuels as well. I wondered whether that was correct. But I've entered that data from your energy balance, and then we also need to put in the efficiency of that process. Now, some of the statistics here I weren't sure were correct. And we can look in more detail at those statistics. For hydro, it's 100% efficient. We assume it's 100% efficient. For diesel, it's important to get the efficiency right to know how much diesel is being consumed. Now, when I do the equation in 2001, I get an efficiency that is over 100%, which obviously can't be correct. So if I look at the energy balance here, and I look at the amount of diesel that is generated, the amount of electricity produced from the using diesel is listed as 445 tons of oil equivalent. Now I've converted that from gigawatt hours to tons of oil equivalent. And I then divide that by 0.44, which is the amount of electricity produced. And I get a result that is over 100%. I'm not sure that can be correct. When we get to later years, we get something that looks more reasonable. So if I look at my electricity production, and I look at diesel and gas oil, I have 808 tons of oil equivalent consumed, and then a electricity production that is lower than that. So the value is less than is less than 100%. And these values of 36% seem to me to be more reasonable. So I've then entered the process efficiency into LEAP and the percent share to these values. To be able to accurately calculate the emissions from oil and gas and from charcoal making, the only things that I have entered are the imports and exports. So in your energy balance, we have exports of different fuels, and then we have imports of these different fuels, of kerosene, of diesel, of everything like that. And we then have our and things like charcoal, yes. I have then entered these directly into LEAP. So if we look at oil refining, for example, and our import target, we are now importing all of these different fuels for kerosene, for diesel, for motor gasoline. And then that should allow us to determine accurately the emissions from oil and gas. I'm guessing you don't have an oil refinery in DRC, but I might be wrong about that. If not, then these imports should completely cover the consumption of gasoline and diesel, and therefore you should have no emissions associated with oil refining. So that is as far as I have got with developing the data set for DRC. And I think it's a pretty comprehensive emission inventory for the energy sector. If I look at the results, I mentioned this in my email, I compared them to the results that you got in your third national communication. And I was looking at CO2 in the energy sector to be able to make a direct comparison, because we don't have it for other air pollutants. In 2010, the results show 2,236 gigagrams of CO2 emissions. In 2010, in our data set, we have 1,805. So that's not completely terrible. It's about 20% different, quite close. But it would be useful for you to have a look at this data set and see where you think the differences may come from. The majority of our CO2 emissions are coming from the transport sector. What's interesting is that our trend is slightly different as well. If we look at 2000, we start off here with 815 gigagrams, whereas the third national communication starts with a value that is lower, 600. So they start with a lower value, end with a higher value. We start with a higher value, end with a lower value. So it would be very good for you to review this data set to see whether you agree with the results that we are getting. But I think it is exciting. We can now look at our black carbon emissions from the energy sector in DRC. And as you might expect, residential sector is the largest source, alongside charcoal making and a little contribution from transporters as well. We can look at other pollutants like NOx, and from the same analysis get an estimate of the emissions. Transport making a larger contribution to NOx emissions compared to residential and charcoal, or these still dominate. So as we mentioned during our call, I will now look at your third national communication, see what data we can enter for the non-energy sectors to try and complete the inventory. But please let me know your thoughts on the analysis and the results that we're getting. It would be very useful to know your thoughts. And if you have any questions about the analysis, please let me know. Thank you very much, Adela, and hopefully talk to you soon.